Hello everyone, welcome to Ekeeda platform, and this is Ravindra Jangid here, your electrical faculty. And in this video I'm going to talk about the comparisons between the CSC, that is the classical HVDC, and the HVDC VSC systems. So let's talk about the one by one, the different points which I have included for you and that are written here. That is due to the limitations on the HVDC, that is the limitation on the HVDC VSC wall voltage rating, the VSC systems are at present used with less than the plus minus 200 kilovolt. So that is the range has been declared by the, you can say, the operators, okay, who are actually the controllers who are actually handling this system. So they come to a point that at the present time we can only handle the plus minus 200 kV value, and the 500 megawatt of system. If we are considering the 500 megawatt system, then for that there will be at the plus minus 200 kilovolt value. So that is limitations of, we can say. Now if we are talking about the classical CSC systems, that is the classical HVDC systems, that is going to be operated for the about 300 kilovolt value. For more than the 1 gigawatt value, that is more than enough, we can assume. That is the classical HVDC CSC systems. Okay guys, now the high controllability of HVDC VSC, the high controllability, this is the HVDC VSC and this is the classical HVDC. So high controllability of the HVDC VSC leads to the independent control of the active and the reactive power. So that is kind of the great advantage if we are tending for the controlling. Okay, tending for the controlling, then this is the main advantages, because for handling or for controlling the active and the reactive power independently, that will be a more efficient in controlling way. Now the possibility of controlling SC conditions, that is the short circuit conditions, so it is kind of more controllable. So in what sense it is high controllable? If we are talking about the HVDC VSC systems, in the HVDC VSC systems we are having the independent control of active and the reactive power, that is the first one. And another, the possibility of controlling SC conditions will be improved there. Now so I have taken in the form of you can say the table where the different points I have included. That is the HVDC, and one is the HVDC VSC. This is the HVDC CSC, classical CSC system. Now if you talk about the HVDC, that is the classical CSC systems, in which if we are talking about the constant current source on the DC side, so it is acting as a constant current source on the DC side. And if we are talking about the HVDC VSC systems, then the constant voltage source on the DC side. Okay, now the current on the DC side is unidirectional. So if we are talking about the HVDC transmission system, so whatever the current is flowing in case of the classical CSC system will be unidirectional. It means the current will flow only in one direction. Now here if we talk about the HVDC VSC systems, then the polarity on the DC side is unidirectional. It means it is not going to be changed if there is some fundamental component change in your system. Now third, the polarity on the DC side changes with the power flow. So if we are talking about the polarity related with the classical CSC systems, that will only change on the DC side when there is a changes in the power flow, or you can say the power reversible conditions arises. And here the direction of the current in case of the HVDC VSC systems, the direction of the current changes with the power flow. So all in over, you can say due to the power flow, or you can say the changes in the power flow, there will be the polarity on the DC side that is going to be changed. And in the HVDC VSC system, the direction of current going to be changed, and all will happen with the power flow, or you can say the reversal of the power flow. Now, fourth, the DC reactor maintains the constant current, that is obviously known as, because if you are, that is a smoothing reactor, you can say that is going to maintain the constant current value, as it is not going to allow the sudden change in current. So on and over, you can say that is in general way, that is the constant current is to be maintained by the DC reactor here. Now, the DC capacitor maintains the constant voltage. So in case of the HVDC VSC system, voltage source converter, so here we are going to maintain, or you can say the DC capacitor is going to maintain the constant voltage, and here in the classical CSC systems, the DC reactor is going to maintain the constant current. One is maintaining the current, one is maintaining the voltage. So what is maintaining the current? The current is maintained by the your reactor value, and here the DC capacitor value is going to maintain the constant voltage value. Okay guys, now we will move for the point number 5. Now, the DC filter capacitance is used on the line side of the smoothing reactor. Okay, and here the DC smoothing reactor is used on the line side of the DC filter capacitor. Okay guys, now 6, the line commutated or the force commuted. Here we are going to use the line commuted and the force commuted operation, and here the self commuted operation is to be performed in the HVDC VSC system, so that is actually the better to operate. Now, 7th, the PWM control, that is a pulse width modulation, is very rarely applied, but here in the HVDC VSC systems, so look at this point, the PWM, that is a pulse width modulation control, is usually applied. So we can say in the classical CSC systems, the PWM control method is going to be operate in the some of the cases, you can say, but in the PWM generally we are actually including in the HVDC VSC system. So in the most of the cases of the HVDC VSC systems, the PWM technique is going to be performed there. Now, 8, the CSC and the VSC are the dual systems here, and but here the CSC and VSC are actually the dual system here, not the but, actually both including the same. So now the point number 9, so this is the comparable case for given the power rating. So whatever the power rating is defined for your system, so for the given power rating, the costs are less, so less costing will be seen there, so costing will be less, and here the overall cost is going to be more. Now, cannot feed the reactive power into the AC system, and the reactive power control is possible. Okay, so in the HVDC VSC system, the reactive power control is going to be possible here. We can control the flow of the reactive power. It will be as per your demand on the load side. So reactive power can be delivered or reactive power can be consumed depending on the system conditions and how the system is operating and what is the actually demand of the load, or you can say the consumers. And here if we are talking about the HVDC classical CSC systems, that cannot feed the reactive power into the AC systems. So I hope you have understood all the comparisons related with the classical CSC and the HVDC VSC systems. Thank you so much.